Hello everyone, today we're going to take a look at lesson 2 from unit 1, solving a system using substitution. So in the previous day's lesson, we looked at solving linear systems by graphing the system and then figuring out the solution or the point of intersection. Today we're going to take a look at one of the algebraic ways that you can solve a linear system, and that method is substitution. But first, let's go through and go ahead and try to graph this linear system like we did yesterday. So these are in standard form, these equations. So we're going to need to rearrange into y equals mx plus b. So let's just write that we need to rearrange into that y equals mx plus b, because once we have it in that form, we can easily graph the equations using our slope and y-intercept. We could also use a table of values, but putting it in y equals mx plus b is going to be a little faster. So we'll start with this equation. If we're going to rearrange into y equals mx plus b, I'm going to leave the y there on the left. And I'm going to move the x and the 8 over to the other side, so we'll have a negative x plus 8. From that, we can easily identify our slope. So our slope is a negative 1 over 1. And our y-intercept is a positive 8. So we will begin by plotting that y-intercept at 1, 2, 3, 4, 5, 6, 7, 8. And then we'll graph consecutive points using our slope. So down 1 over 1, down 1 over 1, and so on. And we'll go ahead and connect those dots and extend the line as far as we can, and maybe even a little bit off the graph. All right, and then I'm just going to label this graph with the original equation, so x plus y minus 8 equals 0. We will go ahead and do the same thing with our second equation. So I'm going to move the y over in this case, because hopefully you can see that the y is negative, and we're wanting the y to be positive when it gets rearranged. So I'm going to leave the x minus 28 on the left, and I'm going to move that 4y over to the other side by adding it. And now I need to get rid of that 4, so I'm going to divide everything by 4. We're going to have x divided by 4, 28 divided by 4, and that 4y divided by 4. I'm going to represent this x over 4 as 1/4 x. That'll help us with our slope. And then 28 over 4 is 7. And then we're left with just y. So now we have it in that y equals mx plus b form. So from here we can see the slope of this line is 1 over 4, and our y-intercept is a negative 7. So again, I'm going to plot my y-intercept at 1, 2, 3, 4, 5, 6, 7, and then use my slope. So up 1 over 4, up 1 over 4. And then you can see I'm not going to cross that other graph. I'm going to have to go up 1 over 1, 2, 3, 4. So it's kind of hard to tell. It's a little bit of a guesstimate in terms of how well I drew a straight line where this is going to cross. But we're going to put our straight line. So it should cross somewhere there. My straight line's not so straight. I need a ruler. And extend it in the other direction as well. Okay, and then we'll label this equation as well with the original, which was x minus 4y minus 28 equals 0. And then hopefully we can see that our point of intersection, as I mentioned, is off the graph. So it looks like for that green line, we would have gone off the graph by about 2. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we went off the graph another 2 units. So we can say that our point of intersection is at least 12. And then we went down 1, 2, 3, 4. So it's at 12, negative 4. Okay, but you can see how as we use this method to solve a linear system, we could run into some problems with our accuracy if the points continue to be off the graph like this. So the question is, what if the point of intersection was farther off the graph. Okay, what should we do if we can't use this idea of a graphical representation to solve the system? And that is where the algebra method comes in mind, right? We've been given multiple tools in math to help solve these kind of problems. So graphically is always a choice, but we can also then resort to algebra. So this is where an algebraic method is useful. Okay, so we're going to take a look at what does that algebraic method really look like, and then we'll actually talk through the steps to this. Okay, so we have two equations here that make up a linear system. Whenever we start into an algebraic method, it's always important to first label those equations so when we refer back to them, we know which ones we're talking about. So let's call this first equation just equation 1, and we'll call our second equation in another color equation 2. Okay, so we are going to rearrange to isolate for one of our variables, and we already did so in the previous example, so we'll just rearrange for x, let's say, for equation 1. It really is a matter of choosing whichever is the easiest to rearrange, requires the least amount of steps. So let's say we're going to rearrange equation 1, and that's referring to that first equation for x. So I'm going to leave x by itself, and I'm going to move everything else over to the other side. So we'll have a negative y plus 8. Okay, and I'm going to label this again as my new equation 1 because I've done some rearranging. Now from here, I'm going to sub my new equation 1 into equation 2. Okay, so I'm going to write my equation 2, but wherever I see an x, I'm just going to put a set of brackets because I know I'm going to substitute something else in there, right? I've rearranged for x, so that means anywhere I see an x in equation 2, I'm going to substitute something else in. So my equation 2 originally was x minus 4y minus 28 equals 0. Okay, so now instead of having an x there, I'm just going to write a set of brackets, and then I'm going to leave everything else the same. Now I'm going to take what I rearranged in that first part, that negative y plus 8, and I'm going to substitute that in for x. So that's what I'm going to put there. I'm going to put that negative y plus 8. Okay, and now I'm just going to write it without my brackets. There's nothing to kind of distribute there. And we're going to use algebra to solve. So I'm going to combine my y terms. So a negative y minus 4y is going to be a negative 5y. And then my 8 minus 20 is going to, or sorry, 8 minus 28 rather, is going to be a negative 20 equals 0. Yeah, move my 20 over. And then finally I'm going to divide both sides by negative 5. So we'll get that y equals a negative 4. Okay, so that's part of our solution because we know our solution always has to have an x and a y, right? It's that point of intersection. So you're going to see this often with this method that you're going to kind of, oops, sorry about that. You're going to run out of space. So you might have to kind of continue the work on up over to the other side of the page. So let's just continue our work up over, and I'll draw an arrow to kind of show that that's what I'm doing. So now that we have our y value, we're going to substitute it into one of the equations. Doesn't matter which one, but it's always helpful to kind of substitute it into whatever the easiest. So we've already rearranged for x with my equation 1, so that seems like the easiest to sub into. So I'm going to sub y equals negative 4 into equation 1. Because our equation 1, like I said, was already rearranged. So we had x equals a negative y plus 8. So now I'm going to substitute in a negative 4. So you'll have x equals 4 plus 8. or x equals 12. Okay, so we figured out our x, we figured out our y, so we can say then the solution, or we can call it the point of intersection, is, we always want to put our x first when we're talking about a coordinate, is 12, negative 4, right? We have our x and we have our y for that coordinate. And then oftentimes you're going to see that it's going to require you to solve and then check your work. So we just determined our x value by substituting it into equation 1. So if we wanted to check it, what we should do is we should take our point of intersection we found and substitute it now into equation 2. So let's check in equation 2. And you always want to use the opposite equation from whatever you did in that last step to find your second part of your solution, right? So we used equation 1 up here. So now we're going to just check it in equation 2 to make sure that it works for both. Okay, so if we have a left side, right side of my equation 2, on my left side I have x minus 4y, everything on the left side of the equation. And on the right side we just have 0. So I'm going to substitute in for x and y. So for x we have 12, and for y we have a negative 4. And hopefully as we work through this, we should also get a 0. So it's 12 plus 16 is 28, minus 28 is a 0. So we can see we got the same on the left as we did on the right. So if you wanted to kind of write this mathematically, you can use the upside down triangle with the 3 dots. This means since. So since the left side equals the right side, therefore, so the triangle with the facing upright means therefore. Therefore, the solution is 12, negative 4. That's just a good check. All right, so let's take a look at the actual steps for using this algebraic method to solve a linear system. Okay, so when we are solving a linear system using substitution, we want to use these steps, which we tried to model in that first example. So you always want to label each equation with 1 and 2 and circle them. So when somebody is looking through your work, and even when you're kind of trying to go through and check your work, you can see which equations were used at all times. You then want to isolate a variable in one equation. Again, whichever variable is easier to isolate. So let's just write here, whichever is easier. And that'll become easier to recognize the more of these you do. You're then going to substitute the value of this isolated variable into the other equation, and you'll solve this new equation, and then take that solution and substitute your result into either of the original 2 equations and solve for the other variable. You should check your results in the equation you did not use in order to find that first variable value. And then you can conclude in the form that the solution, or the POI, is, and then whatever you found those values to be. So let's give it a try with another example. So we'll call this equation 1, and we'll call this equation 2. Now we want to, again, rearrange whichever is going to be the easiest. So if you take a look here, we only have one term that is a variable all by itself, right? This x has no number on it. So that's going to be the easiest to isolate for. So let's go ahead and we will just say we're going to rearrange equation number 2 for x. Okay, so I'm going to leave x on the left, so that work's done for me. And then we'll move the 3y and the 21 over by adding them both to the other side. And this is my new equation 2. So I'll just label that as equation 2 again. Okay, so now that we've done that, we're going to sub our new equation 2 into equation 1. Okay, so anywhere that we see an x in equation 1, we are now going to substitute in this rearranged formula we've made. So let's first just write our equation 1. So our equation 1 was 5x plus 2y minus 3 equals 0. So we're substituting something in for x. So I'm just going to rewrite this equation, but now instead of an x, I'm going to put a brackets there because something else is going to get plugged in there. Plus 2y minus 3 equals 0. And this is where we're going to take that rearranged part and we're going to substitute it in. So we're going to substitute in that 3y plus 21. Okay, we can go ahead and distribute. We have a number outside of a set of brackets, so 5 times 3y is 15y, plus 5 times 21 is going to be 105, plus 2y minus 3. If we combine our like terms, we should get this. And then we're just going to use algebra to solve. So we're going to move that 102 over by subtracting. And then finally we'll divide both sides by 17. And a negative 102 divided by 17, you should get a negative 6. Okay, so that's one part of our solution. Okay, we're going to take that negative 6, and since we've already rearranged for x, we might as well substitute into equation 2. So let's just write, we're going to sub y equals negative 6 into that newly rearranged equation 2. So just to remind us, equation 2 is x equals 3y plus 21. And we're now going to substitute in a negative 6 there. So you should get x is equal to 3. And now we want to check it. Remember, we're going to check in whichever equation we did not just use. So we just used equation 2, so this time we're going to use equation 1. So opposite from that one, right? We used equation 2 there. We're now going to use equation 1. So we'll do a left side, right side check. So my left side of equation 1 was that 5x plus 2y minus 3. And my right side is just 0. I'm going to go ahead and substitute those values in. So for x, I had 3. And for y, I had a negative 6. And we'll simplify some of this. So 15 minus 12 is 3, minus 3 is 0. So again, we can say since the left side equals the right side, therefore the solution is, put our x value first, which was 3, and our y value second, which was a negative 6. Now, just something I want to draw your attention to that you might see in your homework. Is you might see an example where the rearranging is kind of already done for you. So what I mean by that is, let's say you had an example that looks something like this. We had y equals negative 2x minus 8, and we had y equals 5x plus 6. Okay, the first step if we're going to use substitution is we're going to go ahead and label each of those equations, equation 1, equation 2. Okay, the next one is that you would isolate your variable. But hopefully you can see here that I already have 2 isolated variables, right? These are both already isolated, so there's no need to make more work for ourselves. The isolation part is already done. So we would skip that and we would go right into, sub equation 1 into equation 2. Okay, so again, if we were going to sub 1 into equation 2, I always like to start by rewriting the equation I'm working with. So if we're working with equation 1 was y equals negative 2x minus 8. But I'm going to substitute that into equation 2. So instead of writing y this time, I'm going to put a set of brackets there. Okay, and now my y value from equation 2 is going to go in that set of brackets. So we're just going to have 5x plus 6 there. So when it's a y equals something and a y equals something, you're essentially just setting those two equations equal to each other. And then you'd carry on solving for x and then substitute in to solve for y. Okay, so just a little heads up to give you, that's a little bit easier of a situation than having to isolate. Okay, that's it for today.